Hello, welcome back to your last video lesson for this week. This should be Thursday of your first week because tomorrow you have your first test. So there's no video with tomorrow's lesson because you'll be taking your test instead. Okay, let's start out. We're talking about some geometry today. Let's start out by talking about points. So here I have a circle and then it gets smaller, 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 smaller. Eventually it would get so small that you wouldn't be able to see it at all. Well, when that were to happen, we would say that that is the same as a mathematical point because a mathematical point technically can't even be seen. But in order to work with it, we have to show it. So that's what we would call a point. Just a dot is a point. We have also lines that we work with, a line. So that is a bunch of points going in straight across. A bunch of connected points going straight across is what we would call a line, and it goes in either direction. Any bunch of points connected is called a curve, but once it's straight, we call it a line. We can name our line according to the points that are on that line. So here on this line I have A, B, M. Those are three of the points on that line. So I can name my line by drawing a bar with arrows on either end and then picking two of the points. Any two, it doesn't matter, and writing those below that bar. So I could call it line AB, line BA, line BM, line AM, line MB, line MA. It doesn't matter which 2 points you pick or in what order. You're still referring to the same line. Now, if you want to talk about just one part of the line, from one point to another, we call that a line segment. From one point of a line to the other is a line segment. So our line segment, let's say that we picked from A to B, and we just want to talk about that portion of the line. Then we would just draw a bar, and then we use those 2 points in either order. So that could be segment AB or segment BA. So no arrows on either end of the line to show that those are the segments. Well, we could also have something called a ray. A ray starts with 1 point and then continues infinitely in another direction. So it starts with 1 point, continues infinitely in another direction. This is a ray. So here in blue I have a ray. Starts with point P and then goes through points Q, X, and keeps going infinitely in that direction. So to name this, I would draw a bar with an arrow only on one end. So a bar with an arrow only on one side. Then to name it, I start with the first point. So the point that my ray starts with, which is P. And then either of the other 2 points on the line. So I can name it PQ or PX. And that's how you call those. Let's talk for a minute about angles. An angle is when you have 2 rays that intersect, and their point that they intersect is called their vertex. So this is an angle. They have 2 rays, they've intersected, and their point of intersection is their vertex. And I just dropped all my cards, so excuse me because I'm going to go down for a second. Okay, back. So an angle, now I don't have a card showing a right angle. I have no idea why. So I'm just going to cover up a triangle card as best as I can to show you a right angle. Okay, so a right angle looks like this, where the sides are perpendicular to each other. And we have a little box in the corner that shows that this means it's a right angle. So the sides go straight up and down from each other. They are perpendicular. So they cross, and this angle, the right angle, is always 90 degrees. So a right angle is always 90 degrees. An angle that's less than 90 degrees we call an acute angle. Acute angle. Acute angle. We can remember that, and then it's a cute little angle because it's less than 90 degrees. An angle that is greater than 90 degrees, we call an obtuse angle. Obtuse angle. So that's any angle that is greater than 90 degrees. If you have an angle that is so great that it becomes a straight line, so its ray goes all the way back. So that is a straight line. We call that a straight angle, a straight angle. Now notice a straight angle could be made by taking a right angle and another right angle and putting them together. So one right angle is 90 degrees. The second right angle is 90 degrees. So altogether, your straight angle is 180 degrees. So you have right angles that are always 90 degrees, straight angles that are always 180 degrees. Acute angles are always less than 90 degrees, and obtuse angles are always greater than 90 degrees. Okay, the final part of our lesson today is perimeter. Perimeter. This comes from a Greek word. Peri, the prefix peri, if this is in your book, means around. And the Greek word metron, that means to measure. So when we're measuring perimeter, we're measuring around a shape. So look at this shape. If I want to know the perimeter, all I have to do is add up all the sides. But notice, some of the sides are missing, some of those measures. So I can figure that out though, because according to my problem, if you look at example 9.1, it says the dimensions are in feet and all angles are right angles. So that means that none of these sides are slanted, which means that any side that is directly across from another side would be the same length. So see, this is 8, this is also 8, so these are the same. So that means that this distance is the same as this distance. So since this distance is 6, this distance would also be 6. I only have one more side that's missing, this one right here. But guess what? I actually don't even need to find it, because I know that from here to here is 14. So that means that this side plus this side plus this side equals a total that is the same as this side. So if I were to bring this side all the way down, it would come from here to here. This side from here to here, and this side from here to here. So altogether, this side equals 14. So that means I have 8 here, plus 14 going across, plus 6 plus 6, plus 8 here, plus another 14. Oops, I'm running out of room on my board. And I would add those all up, and that would give me a perimeter of 56 feet. Okay. So we are on the last part of this lesson. This is your practice, is to find the perimeter of this shape. So go ahead and pause your video and do that now. Okay, according to your practice, it says that all angles are right angles, so nothing is slanting, and all of your dimensions are in centimeters. So once you find your perimeter, you have to put your unit of centimeters behind it, just like I put my unit of feet here behind the problem that we just did. So you wanted to add all of these sides, but you're missing a couple of pieces. Well, I'm missing this piece here and this piece here. Well, this piece here is the same as this piece here plus this piece here. So 15 plus 8 is what? 23. This piece plus this piece is the same as 14. So I know that both of them together equals 14. This piece plus this piece. So now I can add it all up. I have 23 on the bottom, plus 15 plus 8, which I know is 23, 23 again for the top, plus 14 on this side, plus 4 plus this, which I know is 14 on this side. And add that together. So I would get 3 plus 3 is 6, plus 4 is 10, plus 4 again is 14. Carry my 1. 1 plus 2 is 3, plus 2 is 5, plus 1 is 6, plus 1 is 7. So I have a total of 74 centimeters for my perimeter. So that's how you find perimeter. Let me know if you have any questions. That's the end of this lesson. So super fast and easy for you guys today. I want you to go back over your book, study the lessons that you've done since the beginning of when we started, to make sure that you understand everything for your test tomorrow. Do your very best. Remember, you cannot use anything when you take your test. Okay, have a wonderful day, wonderful weekend. Love you guys so much. See you in the next lesson. Bye.